Good evening, everyone. So here is how I ended up transforming the code into something that would generate some ideas, and we start printing an agent when we implement a print statement. We launch a print statement against an agent is going to be printing everything inside the agent as opposed to just having to print one thing at a time. I ended up let me actually show you here the model. The model here, as you can see, it generates a random ID for each one person, and it's an A number here as we talked about, and also generated a population here. Here's we generate the population by getting a unique ID for every one of them, and then we create an agent for each one of them. So this is my ID here, and everyone is a student as a starting point, and then we discuss the binary representation of vaccinated, negative, military lifestyle, and sports person. And then I also created some interesting functions. These functions are um, basically selecting an interaction. I made this model very simple, much simpler than interaction with classrooms and things like that. So I basically said, if we can decide the percentage of interaction, say we have 100 people, we can decide the percentage of interaction, like maybe 60% interaction among everybody on campus, and that would be selected at random. This is exactly what I did here. And then everybody was been introduced as vaccinated originally. So I also changed this part here by giving maybe like I don't know, a certain percentage for people to be non-vaccinated, but the default is definitely vaccinated. And then I also created this infect an agent, which is essentially going into here. This is the guy that needs to be infected from. So this is negative here. When I flip this to zero, is going to become positive. So I basically did that based on also a percentage as well. So so I would say my infection rate, say 3% or something like that. So based on this, if I have 100, then three of them will be infected, and that bit will be flipped from 1 to 0. That's exactly what it is. And then I created another function that called spread the infection. And spreading the infection, well, before spreading the infection, there was a very interesting function. Yeah, the select interaction, that was essentially finding any pairs of interaction to be interacting with each other, and I returned those as a list of tuples. So my list of tuples are basically going to be A numbers are being interacting with each other. So here, using these pair of interaction, I'm basically taking the A number, and I'm saying if this A number, well, I think it's an index, not a pair, not an A number. I printed it as an A number, but it's just essentially an index for the element in the list. So if the element in the list, so this is how I pass the pair. The pair zero here is essentially the first element in the pair, and so that's going to give me an index. When you pass this, you're going to get the actual agent. So if this patient here, or this agent, happens to be negative, then I infect the other guy. Sorry, I mean, if it's positive, then I infect the other pair in the pair of interaction. That's what I do it. And vice versa. If the pair to the right is infected, then I also infect the pair to the left. And I return those guys. This is all there is. And this is just running the simulation one single time, one single pass. If you want to think about it as like one day in 365 days, or however number of days in a calendar of academic years. So maybe, I don't know, like maybe, I don't know, 144, or maybe 200 days out of 365, or maybe I don't know, maybe 275 days. So this simulation should be run 275 times, except that I'm only running it one time. So let me come here, and my screen is already clear. I'm just gonna run this Python file, and as you can see, I created this class. It's a model class, but the file is called model. And then I also changed this agent guy. I called it NU agent, which is Norwich University agent. So I'm just gonna run this guy here, and let me show you here. Okay, so I'm basically asking for the population size, and my population size example could be 20, but I'm probably gonna enter 30 anyways. Then the people who are vaccinated, let's say you want one fourth of this percentage to be non-vaccinated. I don't know, you can put anything else. You can make 10%, and you will see here those who are not vaccinated, they're gonna show that they are vaccinated. So as you can see, the agent is now printed really nicely. We have an NU ID, which is an A number. Everybody's a student. And here are the features, which is vaccinated, negative, military, sports. Only one, because I only had 10% from 30. So apparently only one person ended up getting infected, which is this getting switched to non-vaccinated versus vaccinated, because everybody else is vaccinated. This is vaccinated right here, vaccinated. So I had to introduce some people who are not vaccinated. So that's how I ended up doing it. Now I want people to interact with each other. Let me see if I can do this like that. So the interaction, maybe we want 50% of the population to interact. Maybe we want more. I'm going to use 75%. So here is my 75%. I don't know how many number of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 out of 30 that we entered originally, right? We entered 30. So we have 22 of those are interacting with each other. Now I want to infect about maybe, I don't know, 1% of the population, which is going to be 1% of those guys interacting. So actually 1% of the original population, because whether they are interacting or not, it does not matter to me. But this is going to become an interesting thing when we are infecting. So my infection rate here is, I don't know, maybe I want to make it 5% infection rate. And you immediately realize now that those who became positive, their agents are going to be printed differently. Here it says COVID positive, COVID positive, COVID positive. We started with only one of them that was actually we started 3 of them were positive. I apologize. We started with just one was positive. All of them were negative actually. And then we ended up infecting 3 of those guys. This is how we infected them. 3 of those, 5% is 3 of those guys turned out to be positive. And now when we are spreading those guys are going to be spreading more infection. So those 3 ended up doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Apparently the spread is working. So we have about 15 people being infected from the 3 that were originally starting. So this is basically we can start visualizing things. We can start generating numbers as we're counting them. The way I'm counting them right now, we can just generate them in a list or something, and then we can plot them. We can do so much with this, but this is exactly the kind of thing that I would like to see. I simplified it so much from what we discussed in class. What we discussed in class was about buildings and students and classrooms and campus. Here is just a population. And instead of having these rules of interaction by if you're in the same class and you're switching from one class into another based on a schedule, I just simplified it by making this interaction at random. there's nothing that should stop us from doing the kind of rules that we discussed. I just wanted to show you one way of how we can do this, but I am suspecting that you guys are going to do things the way we discussed it during class, and I look forward to seeing your work when I return back on Wednesday. That's it for today, and we will talk some more. Let me know if you feel free to comment on the video. Feel free to write me an email, and if you also want the source code, I'll be very happy to send that to you as well. Just let me know what you need, and thanks again, and I will be seeing you guys on Wednesday. Thank you so much.